So we're in a position with this blue light mechanism, blue sky mechanism in hand to start talking about red sunsets a little bit now too. So I get to draw my favorite picture here. Here's the Earth down here, and here's a person standing on the Earth. And here are some of those nitrogen and oxygen molecules, that wispy stuff in our way upper atmosphere. And what we know that if you're red light, not a lot's going to happen. If you're orange light, not a lot's going to happen. If you're yellow light, not a lot's going to happen. Just going to go right on through. And if you're green light, to a large extent, not a lot's going to happen. But if you are blue, you start to interact with that structure of the nitrogen oxygen right there. And you are going to scatter in all directions. Right there, you hit the blue, you're going to scatter in all directions. Keep going this way. On the blue, you're going to scatter in all directions like that. And so what you're really seeing here is, if you think about it, let me draw the blue beam going in sort of in this direction really thick. The blue was originally going this way, right? But all of these things here, all these little scattering parts that you see that ended up making the sky look blue to us, because they travel all the way down to the Earth here, all the way down into our eyes, and makes the sky look blue. Wouldn't you agree here that this blue here sort of left the original beam? Wouldn't you agree with that? Because the blue light was going this way originally. That's the direction it came from the sun. But as soon as it encountered our air here, you start seeing these blue beams leaving the original beam. And so what happens is, you look forward like this in the direction the beam was coming from. Like, say you're able to go up in a spaceship and look at all this light right here, from this position right here, you would notice a definite absence of blue. You'd be like, hey, there's no blue. Where the heck is all the blue light? Well, you know what happened to it. It started colliding with all the nitrogen and oxygen. It got sent in all kinds of directions, mostly up and down. Now, I'll grant you then, some of the blue light will go forward. Not all of it leaves, but a lot of it was removed. And so again, if you were in this position right here, you'd look at the light going, well, where's all the blue light? It's white light from the sun, I know, but for some reason the blue is missing. And you would have to conclude that the Earth's atmosphere is in between, scattering all that light out. And so you can sort of come to a little silly summative equation if you want here, but you can basically say something like white light, like from the sun, plus our air. What that's going to be equal to is basically light with no blue. That's sort of what you're going to get. That's exactly what happens. So our air then, you can think of our air then in the atmosphere as sort of a big blue removal mechanism. That's a great way to think about a blue removal mechanism. And so we know it's not, the blue light isn't disappearing or getting gobbled up. It's just getting sent in different directions, getting scattered out. But when I say blue removal mechanism, you have to agree, though, that this blue light, which was part of all the greens and yellows and orange and reds initially, just isn't there anymore because it got removed. And so this exact reason tells us why sunsets look red then. So let's just think about it a little bit. It's really just about some geometry here, but that same effect. So what is the sunset about? Well, the sunset's something like this. Here's the Earth like this, very similar perspective, and say you're down here sort of rotating away from the sun as it's becoming nighttime to you. And so what's happening, of course, is the sun is here in the sky, getting kind of low in the sky here. You know, there's the lie, the sunset and all this business, but we won't worry about that now. But what's happening then is here's all the atmosphere, and you have a lot of atmosphere between you and the sun in the setting position here. So this is something to consider here. This is sort of the setting geometry. And there's two things in the setting geometry here, right? One, the sun is very low, and two, light passes through a lot of atmosphere. That's the geometry, right? And the reason, so you can see the two bits of geometry just right in front of you here. The first one, the sun is very low in the sky. There it is, it's getting low. And because it's low, light has to pass through a lot of atmosphere on the way to your eye. So here's like a light ray that's leaving the sun like this. And let me maybe draw it in this color. Here's the white light ray coming from the sun. Has to pass through this much atmosphere and more 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 atmosphere as it gets to your eye like that. So what happens to light when it passes through that much of our air, what happens to it? Well, I think you know now. White light from the sun plus air is light with no blue. And so what happens is as this light ray starts trudging through the atmosphere, all the nitrogen and oxygen in there, what happens to it? Well, the blue just starts to leave. The blue goes up this way and down this way and up this way and down there. The blue all start to leave like that. So there's a lot of little arrows to draw here, but the blue just starts leaving the beam like crazy. And not straight as neat as I'm doing. It leaves in all directions. It leaves this way and that way and that way. But sure, some of it goes forward. I'll grant you that. But a lot of it just leaves here, right? So you can label all of this blue light here is leaving and leaving. And so what do you have left? Well, when you look back at the sun from where you're standing here, you're looking at the light coming from the sun, you see all that light with no blue in it. So you have to think now, well, what does light look like if it doesn't have any blue in it? Well, the reds are going to be there because they're not blue. The oranges are going to be there because they're not blue. The yellows are going to be there because they're not blue. Yeah, there'll be a little bit of a green in there too. But look at what you've drawn here. When you take the blue out of white light, look at all these colors you have here. You have red and orange and yellow. All right, maybe a little green, but a lot of red, orange and yellow, red, orange and yellow. Those are the colors of the sunset. Think of the sunset now. These colors that you see here, these are colors of the sunset. And so that in a nutshell is why sunsets are red. The thick atmosphere at this geometry removed the blue. And here's another equation for you right here. White light minus blue light is equal to, let's just say, orange reddish light. And that's the sunset reason for you right there. So see, it's exactly the same mechanism as the blue light, blue sky reasoning. It's just a geometry thing here. You see that when the sun's really low in the sky, the white light has to pass through a lot of atmosphere on the way to get to our eye. And so all that blue gets removed. And if you take white light and you subtract out the blue, you're just left with the orange and the reddish light. And so that's why sunsets are red.